Okay, year seven. So hopefully you have had a little chat about this simulation before you got started and you're looking at this worksheet. So obviously it's very tricky to manipulate the variables when we're looking at photosynthesis. I mean, it's doable. You can increase CO2 levels in the water. Obviously, we can change light intensity by moving lamps around. You can change the temperature, but it takes a long time to have an effect on a plant for you to be able to measure it effectively. So we tend to use simulations so that we get a more uniform effect. It's easier to track the change. It also removes some of the errors in terms of the bubbles, which is what we're going to count today. As obviously in the simulation, the bubbles are going to be generated at a particular size. They're going to be the same size every time. Whereas obviously in reality, if you look at the piece of pondweed that's set up, the bubbles that come out can be very tiny, or they can build up and you get one big bubble, or you can get bubbles that get trapped on leaves. So do they count? So this is to try and eliminate the kind of practicality issues of the practical. So you should have this worksheet to look at. And what I'm going to do is I'm going to run through each of the settings on the simulation because you can no longer run it because Apple don't allow Flash plugins. And all of the photosynthesis simulations that currently exist seem to use Flash. So we've put together this little video so that you can count the bubbles for each of the settings and you will be able to plot your data to show your results and reach your conclusions. So I will first run through the light intensity. So I will go through each of these ones so that you can count your number of bubbles at over 30 seconds. Then I will do the carbon dioxide, either full or half carbon dioxide, obviously with the light setting at its highest intensity so that we're controlling that one. I won't be changing it. And then we'll look at the 3 different temperatures. Obviously pause the video so you can fill in your conclusions as we go along and creating your data table and so on. So let's have a little look at the simulation. So this is our simulation. So obviously we've got a light intensity here, how much carbon dioxide we've got here, and we've got a temperature here. So I'm going to put the temperature at room temperature as my control for the first one, CO2 full, and the first experiment is at 0 light intensity. Our time will be here. I'll stop it at 30 seconds. You will be watching from bubbles coming from down here, guys. Okay, so let's run our first simulation. Okay, so write down your first one. We'll move our light intensity up to the next number, which is 5, and we'll start again. 30 seconds starting now. Okay, stop, and up to 10, and we'll start our 30 seconds again now. That's our 30 seconds. Next light intensity, and we'll start now. Okay, and then to our next light intensity, we're now at 20 and starting now. Okay, and 25, ready to get started, starting now. And on to our next one, 30 seconds, we're at 30 now. And ready, starting now. And stop. Let's move us up to 35. And we're ready to go. Ready, starting counting now. Okay, we can stop with that one. We've got 40. And we can start counting now. Okay, stop. And 45, nearly at the end of our light intensities. And start counting now. And then our last highest light intensity, 50. And we can start counting now. Okay, and stop. Okay, so you should have, now guys, going back to our worksheet, you should have all of your data for these one. Obviously you can skip back in the video and watch again if you think you might have miscounted. You could do it technically as repeats if you wanted to. So you should be able to answer your questions. I'm going to move on because obviously you can pause the video to the carbon dioxide affecting it. We've only got 2 settings on this one, so you're not going to be able to draw a graph from this. There's not enough data points to do a line of best fit. But I will leave the light at its highest intensity. We'll do a measurement with the CO2 at the highest level it can be, and then we can halve the level that it can be. So we will do full first, as your sheet does, and then half afterwards. So 25, lights at 50, we have a full CO2. So our 30 seconds starts now. Okay, stop counting. And now we're going to halve the amount of CO2. So I'm going to reduce the amount of CO2 that is dissolved in the water. We'll leave the light at 50 so we can still compare it. We won't change the temperature either. So we will do our count with half the amount of CO2. Are we ready? Go. Okay, so hopefully you should have your 2 CO2 datas filled in now. So you should have a full CO2, half CO2 setting. So you can go and write your conclusion. And like I said, you can pause. I will move on to how the temperature does. We have 3 possible temperatures, but first you are going to need to create a data table to input your values for the 3 temperatures. To give you a hand with making that, I can tell you that the 3 temperatures that you can use are 10 degrees Celsius, 25 degrees Celsius, and 40 degrees Celsius. So we will start with 10, we'll start with the lowest. We'll have our full CO2 on there, okay, so as much CO2 as possible. And we'll have the light setting high, and we will do our first 30 seconds. So start and stop at 10 degrees. This is our first one. Okay, so that is our 10 degree finished. Let's change the temperature to 25 degrees. And we have our 30 seconds. Okay, and then our final one to measure the highest temperature, which is 40 degrees. And we'll run our 30 seconds. Ready, go. Okay, so you should have all your data. But before you go and put together all your things. Something that is worth noting, guys, if this bottle is full of CO2, there's less CO2 in the water over here. So the full CO2 bottle means there is less CO2 in here. The half CO2 bottle means there is more CO2 over here, okay? So on your results table, where you've got your full and your half up here, full CO2, that means you have the least CO2 with your plant, and this means you have the most CO2 with your plant. Okay, hopefully you are all sorted and you can get to drawing your graphs and writing all your conclusions.